Exercise 517 is going to be our first method in the series of exercise. We're going to start by a problem where we have to display a random matrix of binary number, which size is specified when you call the method. So from the point of view of the main, I have already here the skeleton code. From the point of view of the main, that means that I'm going to be able to call this method print matrix that the exercise requests me to write. Pass as parameter the size of the matrix, so this is going to be in this case a 3 by 3 matrix. Okay, so this is how I'm going to use the method. It's sometimes a good idea to put yourself in the shoes of the programmer that's going to have to use your method so that you can define what you need to pass, what you need to receive from that method. Then we need to write the code of the method itself. So public static, we are not returning any value, so the return type is void. The name of the method is print matrix, and the parameters, well, there's only one, an integer, that we are going to name n. And this is it. We have now to complete the body of the method, so we're going to start doing little commands, like we always do. So the first thing we need to do is, for each row of the method, we're going to display a row. Then this is going to be taken care of by a loop. Okay, what kind of loop? A counter control loop. For each row, we are going to have to do for each column in this row, display a random value. So this is going to be the last step, display a random Boolean value. Because we need to display a random Boolean value, we'll need a random number generator, pseudo-random number generator. So initialize pseudo-random numbers generator is going to be the first step inside of our method. So we have an ID here, a sketch. You can make it as a flowchart. You can make it as a set of commands like I did here of what this method needs to do. Well, let's start by the simple things. For example, initialize a pseudo-random number generator. We have been doing that countless times. So I need a variable random. Let's call it RND. New random. This variable is going to hold a reference to a new object of class random that I just created. Now, for each row, we're going to use a for loop. Okay, it's a counter control loop. Why not using a for loop? For int, let's call it I equal 1, I lesser than the size of the matrix, I++, and I'm going to have here the body of my loop. The body of my loop is going to go up to here after display the Boolean value. Inside of this loop, well, obviously I will have another loop, so let's get rid of that code as well. For j equal 1, j lesser than n, there are as many rows than there are columns in this matrix. I'm going to do something, display a random Boolean value, and after that, I'm closing the body of my inner loop. We have already taken care of the structure of the method. Now, the core of the method is displaying this random Boolean value. So let's go for it, system.out.print. If I use println here, for every value, I'm going to go to the next line. This is not at all what I want to do. Okay, I want to display, for example, 3 random Boolean value in a row of the same line, then go to the next line. Go to the next line when I go to the next row of my matrix. So here I'm going to use print so that I don't go to the next line for each value I display. And I'm going to call rnd.nextInt 2, which is going to give me a random number between 0 and 1 inclusive. Now, as soon as I'm done processing all of the columns of a given row, system.out.println is going to allow me to go to the next line. So let's save this code. Now we are going to compile it, Java C, e517.java. Okay, compilation is fine. Now let's try to run it. Okay, there we go. We have 0, 0, 0, 0. So we have 2 rows and 2 columns only. So let's go back to the code real quick. We have a little glitch to fix here. Classical of A01 bug. If we start at 1, we continue until I and j are lesser or equal to n. So this is what we have here. I'm going to save this code again, go back to Conqueror, compile, and we're going to run it again. And there you go. So a lot of 0 in our matrix, but we still have a couple of 1 here. If we keep like executing it, you will see that this is a random pattern. I'm going to display against the code, and we are done with this exercise.